Hello, so in this video I'm going to talk about how we can still represent data in a table format, but I'm going to talk about how we can group data together. So up to now, say for example this was my data set, I could say, right, I'm going to have a column which is going to have all my numbers in, and then I'm going to have a column which represents the number of times that number comes up. So I put all my numbers in, 0, 0.5, 1.7, whatever, and I'm going to just have the number of times that comes up. That number comes up. But how I'm going to represent it in this video is in a slightly different way. And this is actually how it's most commonly represented. And this is probably an example of how you would get your data in the exam. All right. So how I'm going to do it now is I'm going to say, right, I'm going to give, instead of just one single value for X, I'm going to give a range of values. So in other words, I might say from 0 to, I don't know, let's say from 0 to 2. Okay, well, how many values fall under the bracket from 0 to 2? So from 0 to 2, well, all of these numbers fall within 0 to 2, don't they? So how many numbers have I got from 0 to 2? Well, I've got 3 numbers that lie from 0 to 2. Then let's say maybe I might do from 2 to 4. Okay, it doesn't have to be equal intervals. Maybe if I just make from 2 to 3, for example. How many numbers have I got from 2 to 3? Well, I've just got the one number which falls in the range from 2 to 3. Okay, then I might say, right, I'm going to do 3 to, I don't know, 4.5. They don't even have to be whole numbers. So how many numbers fall between 0 and 4.5? Well, 3.7, 4.2 and 4.3 all lie within the range of 3 to 4.5. So that's 3 numbers. And then I might say, right, from, I don't know, so from 4.5 to 5. How many numbers fall in the range from 4.5 to 5? Well, just the one number lies in there. So that's basically how I'm going to represent my data from now on. So let's look at an example. So let's suppose I've gone out and I've gone out to the street and I've stopped and I've picked up some conkers. Yeah. And I measured the diameter of those conkers. And I get them to the nearest centimetre. So I've represented it like this. You all know what conkers are. You go out onto the streets, you pick them up. They fall from the trees about autumn time. They're basically a seed. You can eat them, I think. You know, you can put the conkers in your mouth and eat them. And so I've got here, so the diameter of conkers, so from 0 to 2, that corresponds to 26 conkers. So the diameter, so all the diameters that lie between 3 and 5 centimetres, pick up the conkers, find all the diameters that lie between 3 and 5 conkers, and I managed to find 17 conkers that had a diameter between 3 and 5, had 11 conkers that had a diameter between 6 and 7 conkers, and had 6 conkers that had a diameter of between 7 and 10 centimetres, and I'm sure you'll agree that's one pretty big conker. So the question is, how can I work out the mean, the median, and the mode, so the average of this data? Because of course it's grouped together, so I've actually lost some values. You know, when I did before, when I put the data in the table, I lost the values. I just said, right, I'm just going to group all those values together. So there is a certain amount of approximation and estimating involved in this method, and this is actually the type of question that you're probably going to get on the exam. If you're asked to find the mean, the median, and the mode, you'll probably get a grouped data question, but it's not that difficult. Right, so there's something I have to do before I go about calculating stuff. So remember before we'd normally just go, right, times those two things together. But here I can't, you know, so I am going to end up creating a final comment, which is like f times x. Remember that number of conkers is frequency. This is a bit, you know, this is x, but it's not quite at the moment because I've got a range. I just want a single value. Because, you know, if I try and times f times x, if I try and times 26 by... well, what do I times it by? I could times it by 0, I could times it by 1, I could times it by 0.5, I could times it by 2. I have to find a value which I'm going to times it by. So, the way to do that is, first of all, notice that I'm measuring to the nearest centimetre. So I first of all got to sort out my bounds. So what is the largest value? So I'm looking at the range between 0 and 2. What is the largest value, if I'm rounding to the nearest centimetre, that it could be? Well, are you happy that it's going to be 2.5? Because anything up to 2.5, I'm going to round down to 2 centimetres. Okay, so it's to the nearest centimetre. It's just all to do rounding, basic GCSE stuff. The largest value that I can have is 2.5. Well, actually 2.49 recurring. But you know that's basically 5, and there's a proof of that which I'm not going to go into. So I'm going to basically have to look at the bounds. So I'm just going to look at the higher bounds at the moment. So look at the next one. So from 3 to 5, what's the largest value that I can have? Are you happy? It's just going to be 5.5 because anything up to 5.5 will be rounded down to 5. Okay, and let's look at the next one. So 7, so the highest value is going to be 7.5 because anything up to 7.5 I'm going to round down to 7. Likewise, this one, the highest value you can have is 10.5 because anything up to 10.5 we're going to round down to 10. Now I'm going to look at my lower values. So I'm going to look at my lower values, which I can have. Remember, I'm to the nearest centimetre. Well, if I'm from 0, so, 0 to 2, what's the lowest value that I can have? It's still going to be 0. Well, technically negative 0.5, but you can't have negative 0.5 of a conker. So it's going to be 0. Okay, because that's the smallest value that I can have. Maybe you can see clearer the next one. So from 3 to 5, what's the smallest value that I can have then? Are you happy? It's just going to be 2.5. Because anything from 2.5 and above, I'm going to round to 3. All right, so 2.6, 2.7, etc. And then likewise for this one, it's going to be 5.5 because 5.5 to 6, I'm going to round up. I'm going to round up to 6. And then from 6.5 to 7, I'm going to round up to 7. So this is my lower and higher bounds. That's the first step. So now I'm in a position to find what my value is. So basically, I'm looking for a value that best represents this interval. Now, are you happy that the logical one to take is just going to be the middle value? So I'm looking from 0 now to 2.5 because I've got my bounds in there. Looking from 0 to 2.5. So my range of that interval is actually 2.5. It's not 2. Careful of that. You need to notice that it is to the nearest centimetre. So you get your bounds in. You say, right, that interval is not 2 centimetres. It's actually 2.5 centimetres because it's from 0 to 2.5, not 0 to 2. Okay, so I look at the middle value of that. And that comes out, well, what's half of 2.5? It's going to be 1.25. 1.25. So I'm actually going to stick an extra column in down here. I'm going to stick it in a different colour as well, just so you can notice. So this is going to become my x, if you like. It's going to become my representative of my range of values. So halfway between 0 and 2.5 is going to be 1.25. Okay, and again, I'm looking from here. So from 2.5 to 5.5, not from 3 to 5, from 2.5 to 5.5. What's the middle value of that going to be? So you're happy it's going to be a range of, well, what's 5.5 take away 2.5? It's 3. Then I'm going to add on half of 3. So just to find the middle value. So half of 3 is 1.5. So that's going to take me up to 4. And again, looking at the next one, I'm looking not from the range of 6 to 7, not looking at that one. So maybe if I put a cross to all of these now, I'm actually looking between these two values here. Okay, so what's the difference between 5.5 and 7.5? Are you happy it's going to be 2? Well, what's half of 2? It's 1. So what's the middle value of 5.5 and 7.5? Are you happy it's going to be 6.5? Okay, and again, I'm going to be looking at the range between 6.5 and 10.5. What's the middle value of 6.5 and 10.5? Well, it's going to be 8.5, isn't it? Because the difference between 10.5 and 6.5 is 4. So half of that is going to be 2. Add it on to 6.5, and I'm going to end up with, 8.5. 8.5. So this is now my x value. So now I'm in a position to multiply these two things together. So now I'm in a position to multiply these two things together. So this is my extra column, which is what I'm after, and working out exactly the same way. And actually from here on in, it's the same way of working out the mean from here. So let's do 1.25 times 26, which comes out as... So 1.25 times 26 comes out as 32.5. 4 times 17 comes out as 68. Okay. Then I've got 6.5 times 11. 6.5 times 11. So that comes out as 71.5. And then I've got 8.5 times 6. So 8.5 times 6 comes out as 51. Okay. So now I've got everything I need to work out what my mean is. So remember how I work out my mean is my mean is the sum of f times x, so in other words my last column, if I just use the colour coding, which is my green column, divided by the sum of my f's. Sum of my f's, which is the sum of these. So I need to work out the sum of fx and the sum of f. So sum of f is going to be down here. So sum of f is all of these numbers added together, which works out as 60. So I've got the sum of f works out as 60, and then the sum of f times x. So the sum of f times x is all these numbers added together in this column here. So it's 32.5 plus 68 plus 71.5 plus 51, which comes out as 223, I think. So 223. So therefore, I just need to work out that. So to work out the mean, I just do 223, which comes from this box here, divided by the sum of my f's, which works out as 60. And that comes out as 3.716 recurring. So I'm just going to call it 3.72. So my average diameter of my conker is 3.72 centimetres.